Hi everyone. Learning about geometrical shapes and figures is very important in order to build a relationship with the various structures present around us. So, have you heard about a polygon? What exactly do you infer from real life objects? Have you ever seen a stop sign or a starfish? Both are a form of a polygon. In this lesson, we'll learn what is an angle and what is a polygon. So a polygon is any closed shape which has three or more sides. But what exactly polygon means? So polygon actually came from Greek. So poly means many and gon means angles. In simple mathematics, a polygon can be any two-dimensional shape that is formed with the straight lines. So be it a quadrilaterals, be it a triangles or a pentagons or octagons. These are all perfect examples of polygons. The interesting aspect is that the name of the polygon highlights the number of sides it possesses. Okay, like these. These are our sides, and the points where these lines joins are called vertices. These are very important information for you all to remember. So in this slide, we are going to talk about the types of polygons. Polygons are usually characterized into different types of depending on the number of the sides together with the extent of the angles. So some of the main types are regular polygons and irregular polygons. So when I talk about the regular polygons, my regular polygons looks like these. Have you noticed something that all the lines, all the sides of my regular polygons are equal. So that is my one of the fact here, that when all sides of my regular polygons are equal, then in that case all my angles will be equal as well. And when I'm talking about the angles here, I'm talking about the interior angles. The next type of polygons are irregular polygons. And irregular polygons are those polygons that aren't regular, be it the sides or the angles. Nothing is equal as compared to the regular polygon. So for you to see the examples are like that. As we have already covered regular and irregular polygons, there are some shapes which are not considered as a polygon. Which are those shapes? Any circular shape, any cylindrical shape, any 3D shape, or any shape which has any open edge cannot be considered as a polygon. So here we are talking about the interior angles. How we can calculate interior angles? How can we find interior angles? So this is a shape of my polygon. So my interior angles are self-explanatory. They're the angles which are inside the polygon. Now what's the formula to find the interior angles? The formula will be like this, that the sum of the interior angles is equal to n minus 2 times 180 degrees, where n is the number of the sides the polygon has. So we can calculate the sum of the interior angles of a polygon by subtracting 2 from the number of the sides and then multiply by 180 degrees. So in this case, I have 6 sides of the polygon. I will minus 2 from the 6 sides and times it by 180 degree. What I'll get? 4 times 180, which will give me 720. So this is the sum of the interior angles. Now these sum of the interior angles, if I have to calculate the single angle or one angle, then the sum of the interior angle should be divided by the number of the sides given to me, which will be 120 degree each. Now here we are going to talk about the exterior angle. As we have just learned about the interior angles, what are the exterior angles? So exterior angles are also self-explanatory. Exterior angles are the angles which are outside the shape. So these are my exterior angles. So exterior angles always add up to 360 degrees. In a regular shape, all angles are equal. So in a regular hexagon, all external angles will be 360 degree divided by number of sides. So if this polygon has 6 sides, it means 360 divided by 6 is equal to 60 degrees. So my each angle outside of the polygon or exterior angle will be 60 degrees. As we have already learnt about the formula of finding the interior angles before, and the formula is also mentioned on the screen, there is another way as well to find the sum of the interior angles. Now, in order to find the sum of the interior angles for any polygon, what you need to do first is find out how many sides of polygon you have. So in this case, I have 4-sided and 6-sided polygon. Now, identify if a polygon is regular or irregular polygon. Now, if possible, work out how many triangles could be created within the polygon by drawing lines from one vertex to all the other vertices, like these. As I can see, in my first two quadrilaterals, I have 2 triangles, whereas in my third one, I have 4 triangles, which is my hexagon. Now multiply the number of triangles by 180 to calculate the sum of the interior angles. If the sum of the interior angles of one triangle is 180 degree, then the sum of the interior angles of 2 triangles will be 180 times 2, which will be 360 degrees. So the sum of the interior of the quadrilateral here of my first two will be 360, and the third figure, third polygon, which is hexagon, will be 720 degrees. Here is an example for all of us to try. The question is, work out the size of each interior angle in regular octagon. So this is my regular octagon where all the sides are equal. If all the sides are equal, it means all the angles are equal. First, I'll do with my formula, which will be like this, which is n minus 2 times 180 degrees, and I'll find my answer. And after finding the sum of the interior angle, I have to divide sum of all the interior angles by the number of the sides of the octagon, which is 8. So 1080 divided by 8 is equal to 135 degrees, and that's the answer for my each angle here in octagon, which is the interior angle. Now another way of doing this same question is by making the lines or making the triangles within the octagon from one vertex to another vertices, like these, and try to find out how many triangles I can make here. So altogether I have 6 triangles. 6 times 180, which will be 1080, and 1080 divided by 8 sides is equal to 135 degree angle each side. So here's a practice question for you all. The first question is a square a regular or irregular polygon? Actually, it's a regular polygon. Why? Because all the side lengths are same and all the angles are right angles. Hence, a square is a regular polygon. Second question, is a semicircle a polygon? No. The semicircle is not a polygon because a semicircle has a side which is not straight, so it is not a polygon. Third, what is the sum of the interior angles of a triangle? The angles within a triangle always add up to 180 degrees. Fourth, what is the sum of interior angles for a regular pentagon? So as we know, pentagon has 5 sides. Then that 5-sided pentagon can be divided into 3 triangles, and 3 lots of triangles or 3 lots of 180 is 540 degrees. Now these are some questions which we have done as a practice, but there are 2 questions which I want you all to try and send the answers in the comment box. Some exam questions for you all to practice. The first question is, each exterior angle of a regular polygon is 15 degrees. Work out the number of sides the polygon has. It's a 2 marker. It means I'm looking for a workout and the answer. So the answer will be like this. You can always pause the video and try it by yourself. Now here is a quadrilateral in my second question. The question is like this. The diagram shows a quadrilateral and find the value of x. So in that case, I have been given 3 sides angle and I need to find the 4th one. You all remember in our first video I have mentioned the quadrilateral is always add up to 360 degrees. So the sum of the interior angles of a polygon, which is a quadrilateral, is 360 degrees. So what am I going to do? I'll add all the angles given to me plus x is equal to 360. Now 360 minus 259, will give me the angle X, which is 101 degrees. Now question number 3, I have been given a hexagon. Now my hexagon has some questions which says that my two angles are not given to me, but in the question it is mentioned that angle CDE, which is angle D, is twice the angle of BCD, which is angle C. Now there is a hint, okay? Always remember, first hint is it's a hexagon. Second hint is that angle CDE is 2 times the angle BCD. So it means if I say angle C is X, my angle D will be 2X. So how am I going to do my workout? First, I have to find the sum of the interior angles. So what I'll do, I'll use my formula and figure out what is the sum of the interior angle of hexagon, which is 720 degrees. Now I will find out the information for the size of the angle, which is CDE, by doing the calculation like this. So first thing first, I first have to find out the value of X, which is my angle C, which is 67 degrees. And then afterwards, if my C is 67 degrees, it means my angle D will be, which is CDE, is twice the angle of BCD. So it will be 2 times 67, which is 134 degrees. So here is a learning checklist for all of you, that you have now learned how to first use conventional terms of geometry, example regular or irregular. Second, derive and apply the properties and definitions of special type of quadrilaterals. Knowing names and properties of polygons. Calculate the sum of the interior angles of a regular polygon, and calculate the sum of the interior angles for an irregular polygon. Now, there are some common misconceptions when we are doing the questions of angles in polygon. The first one is that you are miscounting the number of sides, then your answer will be wrong. Second is misidentify if a polygon is regular or irregular. Number 3, incorrectly assuming all the angles are the same size. And the last is crossing lines when drawing the triangles. This creates false interior angles. I'm hoping that you all have understood the topic. If you have any queries, please write it in the comment box. Thank you for watching and stay tuned for the next topic, which is bearing and scale. Thank you and goodbye.